Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to learn about the relative motion. This relative motion can be applied for relative velocity, even relative acceleration. But why we are doing this relative motion and all that? Why? Because students, remember that whenever two or more than two objects are moving, then analyzing motion of those objects are very complex. Okay, in real situation this will be very complex, but if we will apply the relative motion, so by applying the relative motion, that real situation we will convert into virtual situation, or we can tell hypothetical situation, and then we can solve the question and the real world problem very easily. Okay, how we can do all these things? We will do by solving questions and all from the NEET and JEE also. Okay, so first let's learn the concept and then we will solve the questions and all that. Okay students, so let's start the video. So here the heading is relative motion. So see here, motion of one object with respect to another object is called a relative motion. That means two or more than two objects can also move, not a problem. Okay, now see, rest and motion of any object is always relative but never absolute. It depends with respect to which reference we are observing the object. Normally what happens that here we cannot tell whether the object in rest or motion in an absolute way. Why? Because if I talk about the earth in a which situation, if we are standing on the earth, we will tell earth in a rest situation. But if we are seeing the earth from the moon, then we will tell the earth in a which situation? Motion situation. That means when the reference is on the earth, then the earth at rest. But when the reference is at moon, then the earth in a motion. That means relative and motion, this rest and motion is always relative. It will never be absolute. Okay, that we can learn by the examples also. You can see the example. The first example, see, as I told you, a person sitting in his house is at rest with respect to earth. I am considering house is at earth only. Okay, but in motion with respect to moon. Is it very clear? As I have told you. Second one, see, very practical example. A driver driving a vehicle is at rest with respect to fellow passenger. Why? Because fellow passenger is traveling with the driver. The speed of the driver and the fellow passenger is same. That's why the driver will be at rest with respect to fellow passenger. But in motion with respect to a person standing on the road. Is it? So I hope so this is very clear. Rest and motion are which term? They are relative term. They are not a absolute. Okay, great. Now students, after learning relative motion, we are going to see the relative velocity. Now, generally 1D, 2D and 3D, that means here somewhat I will use the vectors. Actually the name is relative velocity. Even I can apply this for the relative acceleration, relative displacement. Whatever concept we are learning, that will be applicable for the relative acceleration, relative displacement, or any kind of physical quantity in a vector. Okay, but all these concepts we are learning by the name relative velocity. Okay, so see here, relative velocity of an object A with respect to another object B. With respect to another object B means B is the observer. Okay, is the velocity that object A would appear to object B. As I have told you, with respect to object B means who is the observer? B is the observer. So if B is the observer, what will happen? That when the A is moving, B will observe and it will appear to B. Okay, that is the meaning. Now see here, first one, velocity of A with respect to B is given by. Okay, so first I am writing in a vector form. So velocity of A with respect to B is given by. Okay, I am considering that here. Remember that this velocity of A I have taken V1. Okay, and see here, this velocity of B I have taken here V2. Why I have taken? Later you can understand very well. So velocity of A with respect to velocity B is given by VA minus VB. So I can write here V1 minus V2. Is it? And this is the thing here. After that here, even if you want to write here in a rectangular coordinate system also, vector V1 means we can write here V1x I cap. Later we will see in a motion plane also V1y j cap plus V1z k cap. Is it? Minus. What is V2? We can write here, see, V2x I cap. Is it? And we can write here, see, plus V2y j cap plus V2z k cap here. Is it? Just I am writing here for the rectangular coordinate system also. Similarly here, velocity of B with respect to A is given by. So here we are telling that here with respect to A. Then who is the observer? A is the observer. So velocity of B with respect to A is given by here VB minus VA. Okay. And here who is the observer? This A is the observer. A is the observer. And observer, whenever it is observing, observer will be always at rest. Here A with respect to B means B is the observer. B is the observer at rest. Observer always at rest. Remember that here na. So this one we can apply for 1D, 2D and 3D. Most of the time we will apply these formulas for 2D and 3D. Why not 1D? Because in 1D there is the only two possible directions that can be taken care by plus and minus sign. No need to use I cap, J cap, K cap and all that. Okay. So I hope so. This is very clear to you. Is it? Now we are going to see in this, as we are learning motion in a straight line, we are going to focus on the relative velocity in a one dimension. Okay. So see here now. So here the heading is relative velocity in 1D. Okay. So see here. When object A and B are moving in same direction with uniform velocity, VA and VB respectively then. Okay. VA and VB respectively. So they are moving in the same direction, as I have told you very well. Now let's take here only two possible directions are here. One side positive, one side negative. If forward positive, backward negative. If backward positive, then forward negative. Depending upon the question, we can use sign convention. By default, we will always use mathematical sign convention. Is it? Remember that here for the x and y axis and z axis and all that. Okay. So here what I am telling that here, students, here both the objects are moving in which direction? Same direction here. Is it? So see here. Both these objects are there, is it? And let's take they are separated by distance d. Now, and if I write here, let's take here, this is the object, okay, velocity of, let's take B, B is forward, so velocity of B. In which direction? This direction, so I can write here C plus V1, is it? Here, this is the object A, so I can write here VA, this is also in same direction, we can write here plus V1, is it? And they are separated by how much distance is there? They are separated by d distance here. Is it? So now students see. This also see. I will keep it in a separate here like this. Okay, like this here. Now, so here what will happen that here? If I write here the velocity of object A with respect to object B, vector sign no need. Now in a relative velocity in one dimension, there is no need of vector sign. Okay, so velocity of object A with respect to object B is given by VA minus VB. VA is V1 and VB is what? VB is a V2 actually. Okay, VB is V2. Let's take. Okay, so what will happen that here? It will become here V1 minus V2. Now, so velocity of A with respect to B is given by VA minus VB, or we can tell V1 minus V2. V1 minus V2. Is it? This is the thing. Now after that, if I learn with the example. Okay, so one by one I will see here. Let's take. Tell me one thing. If velocity of object A, that means V1, is equal to velocity of object B, that means V2. So in this situation, tell me please here, both are moving with the same speed, is it? So in this situation, what will happen that here? Velocity of object A with respect to object B will be how much here? It will be 0. How much here, students? It will be 0 because V1 minus V2 both are equal, so it will be 0. So here, if I represent, let's take for example, here I have taken velocity time graph, and let's take this is the V1. Now this is what students say. This is the V1. Now this is the V1, and after that V1 and V2 both are moving in same direction. Is it? That means see here please. When they are moving in same direction with same speed here, is it? So it's like this. Anytime A will be able to catch B, it will not at all be possible. Is it? And let's take for example, this is the origin. What I am taking here, this is the origin is there. Okay, and the B is how much distance ahead? D distance ahead. So this is V1, and what is this here? This is the V2. You can see here, students here. Now both the graphs are having the same slope. No? Both the graphs are having the same slope, and here this is the position time graph. X position time graph is there. X versus T graph is there. Okay, which graph? X versus T graph. Slope of the position time graph will give us velocity. So both will have the same slope. Is it? And anyhow, this distance how much here? This distance is GAD, D, 0, D, as I have told you. Is it? So they will not be able to catch each other. Both are moving with the same velocity. Okay. Now students, after that, if we talk about here the second situation, let's take for example, what is this? V1 is greater than V2. Now, you even think V1 is going faster than V2. He will be able to catch him? Yes, definitely he will be able to catch him. That means what we can write here, see this velocity of object A with respect to object B, what will be this? This will be positive. Positive. Velocity of object A with respect to B is what? Positive. That means he will be able to catch him. So when the velocity will increase, what will happen that here? Slope will also increase. Is it? So V1 is greater than V2 now here. Is it? So this V1 is there now, we will increase the slope somewhat here like this. See. I will just take here some line so that we can draw very properly. See. See like this here. See. Like this here. See. Now what is happening that here? This is the now new V1. Is it? New V1. This is in a first situation. This is in a second situation example. Is it? So here you can see very well when the V1 is greater than V2, what will happen that here? He will be able to catch him. Catch him. Okay? Where? At this time. At this time, what will be there? He will be able to catch him here. Is it? Remember that here because both the slopes are intersecting. Is it? Now, students, after that here, I will take some other color. Now, see here. If in case V1 is less than V2, even you think basically, speed of backward person is less than the speed of the forward person. Anytime he will be able to catch? Never, never, ever. Is it? So in this situation, what will be there? Velocity of A with respect to B will be negative. So when the velocity of V1 is lesser, you know what will happen that here? See, like this here. The slope will decrease here. See, just let me take here the straight line like this here. See, like this. Like this is there. And now what is this? This is the new velocity. V3. Is it? And can you see very well? This V1 and V2 is intersecting. It is not at all intersecting. That means what will happen that here? When V1 equal to V2, both will move with the same velocity. If in case V1 greater than V2, anyhow the object A will catch the object B. If in case V1 is less than V2, object A cannot be able to catch B. Is it? Remember that here all these situations. I have taken situation 1, situation 2 and this is what? Situation 3. Even I can write here, see, situation 1, situation 2, situation 3. Okay? So remember that here all these things here. Okay? Great. Because these graphs are important. Now position time graph is there. Next one is students here. See, what is the scenario? The scenario is what? See the students here. When objects A and B are moving in which direction? Opposite direction with a uniform velocity VA and VB respectively, then okay, anyhow, and remember that here this graph is which graph? This is the position time graph. Okay, again I'm telling you this is the position time graph will be there. Okay, so now again let me draw here. See, so here I can take here this is the A and anyhow now this is B, velocity of VA and velocity of VB. Both are now moving in a which direction? Opposite direction. Is it? Mathematical sign convention. So VA will be anyhow plus V1 and this VB will be how much here? Minus V2. Correct? And the distance between them how much here? D. Now mathematical sign convention we are following. Like this kind of scenario is there. Is it? And if I draw here the directions, they are moving in opposite direction now. So A this side and B this side here. Is it? Is it? So here what will happen that here students here who will be the observer? Let's take I am writing here velocity of object A with respect to object B. What can I write here? VA minus VB. Is it? So what will happen that here? VA is given by plus V1 minus VB is given by minus V2. Then you know very well what will happen that here students here it will be velocity of object A with respect to object B. It will be add up V1 plus V2. Remember that here when they are going in a same direction, it will subtract V1 minus V2. Is it? And who is the observer here? Here this B is the observer. A with respect to B means B is the observer at rest. Is it? And velocities will be subtracted. Now see here. Okay. Now if we talk about here what is this velocity of A with respect to B? Now so here what is this? This B is the observer and which situation? Rest situation here. Is it? So this thing is there. So now students, let's take for example anyhow. Now let's take for example I have taken here. Now I have taken and let's take VA is anyhow. Do you think that here anytime they will cross each other? In all the time they will cross each other. Is it? Because they are moving towards each other, they will anyhow cross each other, is it? So as I have told you very well, VA is plus V1 and VB is what here? VB is minus V2, okay? So here if I write here, let's take for example tan alpha, and here if I write here tan beta, so you know very well here, this alpha will be acute angle, okay? And negative velocity means this beta will be obtuse angle, okay? Remember that here. And anyhow, velocity of object A with respect to object B, what is this? V1 plus V2, is it? V1 plus V2. And separation between them, how much I have taken here? D, okay? So now let me draw here the graph. So first I am going to draw here velocity of object A plus V1, is it? Plus V1 means which slope? Anyhow, acute angle, like this is there, is it? So this I am writing here the V1, velocity of object A. And this angle how much here? Anyhow, anti-clockwise angle, this is the what I have taken here, alpha, is it? And after that, what is happening that here, students, this B at a distance of D, that means let's take somewhere here, no? We can write here 0, D, this distance is D, no? And moving in which direction? Opposite direction. Which slope? Obtuse angle here, is it? So just let me draw here, see, no? See, so now moving in this direction, like this. Is it like this? Let's take for example moving now, and here which slope is there? Remember that here. Now this one here, obtuse angle. Do you think they will meet each other? Yes, they will meet each other. When they will intersect, like this. See here, at this time they will intersect, they will meet each other, okay? And how to get this time? This time, if you want to calculate here, remember that here, speed equal to distance by time, so time equal to distance by speed. How much distance is there between them? D, okay? And how much relative velocity? V1 plus V2, okay? Remember that here, this is the time here, okay? Even I can write here T2, and so this is here T2. After this much time, D by V1 plus V2, they will meet each other. Similarly, if I talk about here, in this scenario, this is the T1, is it? So here what will happen that here, in how much time this A and B will meet here? Distance between them is D. So D by, what is there in this situation? No, V1 is greater than V2. So I can write here, see, V1 minus V2. T1 is what? D by V1 minus V2. After this much time, they will meet each other here, okay? And here what is given here? After this much time, they will meet each other. In which situation time will be lesser? In second situation, anyhow, time will be less because they are moving in which direction? Opposite direction, okay? So I hope so all these basics are very, very clear to you. Is it? Great. Now students, after learning all these concepts, we will solve the questions. Now, so see, the question is what? See, a train of 150 meter length is going towards north at a speed of 10 meter per second. A bird is flying at 5 meter per second parallel to the track towards south. The time taken by the bird to cross the train is how much here? Okay. So remember that here I am following the basic convention: east, west, no? This is south, this is north here, is it? So first thing I am writing here, length of the train, how much is given here? L. Length of the train is given here 150 meter. Okay. After that, what is given here? The train is moving in a which direction? North direction. See, the north is upward here. Na? So let's take, I have taken here. Na? So this train, velocity of the train is there. Na? Velocity of the train is anyhow how much is given? 10 meter per second. So I will take here plus 10 meter per second. Na? Plus 10 meter per second. Upward positive mathematical sign convention. Okay. So velocity of train is given here anyhow plus 10 meter per second. Is it? Now the bird is there. Na? This train is having length L. Na? Train is having length L. Now one bird is there here. Bird is there. Na? Bird is going in which direction? South direction, like this. So here what is this? The velocity of bird will be how much here? Both are moving in opposite direction. So how much is given here? Plus 5 or minus 5, I will write here minus 5 meter per second, okay? So remember that here, students, here, if I write here, see, velocity of the bird, how much is this? The velocity of bird will be minus 5 meter per second. Very basic we are doing in the starting, okay? So only we can understand the concept, okay? So this is my, remember that here, students, this is my real situation, okay? After that, what is there? Both the objects are moving. We have to apply here the which concept? Relative concept. Okay. So what I am going to do here? Let's take. I am going to stop the bird. So if I am telling I am going to stop the bird means the bird is going to be the observer. Okay. So if I write here velocity of train with respect to bird, is it? So we can write here Vt minus Vb. Is it? So Vt how much here? 10. minus 5. What is coming here? 15 meter per second. So velocity of train with respect to bird, how much here? 15 meter per second. That means what is the basic sense? The sense is what? This one, see. Velocity of train with respect to bird, how much here? 15 meter per second. And now this bird is there. In which situation? Rest situation, because bird is the observer. Okay, so this is the situation here. Now see here, I have drawn here the two situations. This is called a real situation, real situation. But to solve the question, we have taken this, and this is called which situation? Virtual situation. Whenever we want to solve the relative velocity based question, the real situation should be transformed into virtual situation. Okay, so now from here you think that here now bird in a rest situation. So if the train wants to cross the bird, how much distance train has to travel? The train has to travel the distance equal to its length only, then only it will be able to cross the bird. So in this situation, if I talk about this time taken to cross the bird, it will be given here L by VBT, is it? So L how much is given here? 150, is it? Velocity of bird, VBT I'm telling here, VTB, is it? VTB, velocity of train with respect to bird, is it? So velocity of train with respect to bird. So VTB how much is given here? See 15. So 150 by 15, how much is coming here? It will come here 10 seconds. Is it? I have explained you all these things, so only it is taking here this much time. Otherwise, we can do very fast, very quickly. Is it? 10 seconds. Is it? So, good. Next students, let's see. This question is here. What is the question? See here. Important for NEET and JEE. Two trains. Before that, there was the train having some length and bird was having the point object. Is it? So when one object is having some length and the object is the point object, there the distance traveled to cross each other will be equal to the length of the object. Now because one of the object is point object. But here you see, two trains each of length 100 meter moving parallel towards each other at speed 72 km per hour and 36 km per hour respectively. In how much time they cross each other? Is it? Here both the objects are having the some length here. Okay, so let's take for example, this is length L, here also length L, this is object 1, not train 1, and this is train 2. Why I have drawn here one up, one down? Because both the trains will never come on the same track. They should be always on different tracks. Okay, so see here, this is the velocity of train 1. Even I can directly write the answer, but okay, anyhow I am solving for you. Velocity of train 2, is it? So remember that here, the length of the train, how much is given here? 100 meter. Okay. And velocity of the train, how much is given here? Velocity of the train 1, mathematical sign convention. So VT1 will be positive, 72 km per hour, is it? And velocity of the train 2, VT2 how much here? Opposite direction, that means minus, so minus 36 km per hour here, is it? So now both the train wants to cross each other. So any one train I have to stop. Let's take I have stopped this train. So if I have stopped train number 2, that means the train 2 will become observer. Okay. So I can write here, see velocity of train 2 with respect to 1. What I am writing here, velocity of train 2 with respect to 1. So what we can write here, see VT2 minus VT1. VT2, which one we have stopped here? We have stopped train 2. So okay, velocity of 1 with respect to 2 we have to write. Is it? 2 we have stopped, velocity of 1 with respect to 2, because 2 is stopped, So see, we can write here, see, VT1 minus VT2. So VT1 how much here? 72 minus of minus 36. So 72 plus 36, it will come here, 108 km per hour. But all the answers are coming in a second, so we have to, converting kilometer per hour to meter per second, we have to multiply with the 5 by 18. Okay, so now we have to simplify this here, 108 by 18, how many times here? I think so 6 times here. So 18, 6, 108, so and 6 into 5, how much here? 30 meter per second here. Is it? Correct only. That means what is the meaning? When the train 2 in a rest situation, this train is moving, velocity of train 1 with respect to 2, with how much speed it is given here? 30 meter per second. Okay, now what is this? This train is there. Now this train 2 in a rest and train 1 wants to cross. So what will happen? First the train 1 will travel distance L. Then again it will travel further one more distance L. Then only both will cross each other. Is it? That means in this situation, if I write here the time taken to cross the train is given here. Total distance how much here? 2L. 2L. Is it? And relative velocity. Velocity of train 1 with respect to 2. Can you put the values here? One train having 100, so 2 trains here, total how much distance here? 200. So 200 by 30, is it? 0, 0, cancel. And 20 by 3, what will come here? It will come here 6.6 second here, is it? That means which option is correct here? Option B is the correct answer. Whenever I am drawing the two diagrams here, this diagram represents the real situation and this diagram represents here the virtual situation. Okay, I hope so. This is very, very clear to you. Okay, great. Now students, let's move to this question asked in a JEE 2023 exam. Okay, so see the question. A passenger sitting in train A, okay, let's take this is a train A, moving at 90 km per hour, observes another train B moving in opposite direction. Now let's take this is the train B is there, moving in opposite direction for 8 seconds. Time is given 8 seconds. If the velocity of the train B is 54 km per hour, then length of the train B is how much here? Okay, so let's take for example, this is the length of the train B. Both are moving in which direction? Opposite direction. That means velocity of A and here anyhow velocity of B. Is it? Opposite direction they have given different tracks. Okay, so first we'll note down the data here. Train A is moving with how much speed? 90 km per hour. Okay, so velocity of train how much is given here? In this direction positive, so plus 90 km per hour. Okay, after that, and the train B moving in opposite direction for 8 seconds. Okay, time is also given here for 8 seconds it is moving here. Okay, if the velocity of the train B is, okay, velocity of the train B how much is given here? 54, but in which direction? Opposite direction. So which sign? Minus sign here. Okay, so minus 54 km per hour here, is it? So they are asking what here? Students, they are asking the length of the train B how much here. Okay, so one passenger is there now. Let's take for example the passenger is here. Now passenger is here. Okay, passenger in train A. No? So passenger A, let's take driver is there. Driver is also, we can tell passenger only, no? Because he is also there in a train. So he is going to this train B is crossing here, no? And we want to know the length of the train B. Anyhow, we'll stop the train B, is it? So if I am stopping the train B, so when I am stopping the train B, that means train B in a which situation? Rest situation here, no? Then what will happen that here? See, velocity of train A with respect to train B is coming here what? VA minus VB, and both in opposite direction, so it will add up. So we can write here, see, 90 minus 54. So what is coming here, students? It will come here 144 km per hour. Convert into meter per second, because answer is in a meter and all. So 5 by 18. Okay. So here what will happen that here, students, here 144 by 18. So it will come here 144 by 18. It will come here 8, I think. So 8 into 5. It will come here 40 meter per second here, is it? Correct, only 40 meter per second, is it? That means what we can tell here, now this passenger is there, now this passenger is moving in this direction with how much speed here? 144 meter per second. This is called velocity of train A with respect to train B, is it? And this is the length of B, is it? So how much distance is there? Now train is taking 8 seconds, is it? So directly we can use, no? Passenger has to travel how much distance? Equal to the length of the train B. So we can write here length of the train B is equal to velocity of train A with respect to B into time. Is it? So velocity of train A with respect to B means 40, and time, how much time is taking? 8. That means how much is coming here? It is coming here 320 meter. Is it? That means the length of train B is 320 meter. Okay, this is called the real situation, is it? And this one is called which situation? Virtual or hypothetical situation. So length of the train B will be how much here? It will be 320 meter. Is it? Great. Now students, let's see here. This question is here. This question came in a JEE 2024. So see here the question is what? See, train A is moving along two parallel rail tracks towards north with speed 72 km per hour, and train B is moving towards south with speed 108 km per hour. Velocity of train B with respect to train A and velocity of the ground with respect to B, how much here? Okay, so let me write here one by one. So see here, I hope so you understood very well. Train A is moving in which direction? North direction. Okay, so see, let's take this is the train A moving in north direction with velocity VA. Train B is moving in which direction? South direction with velocity VB. Is it? So anyhow, velocity of the train A, what can I write here? Remember that here, we can write here plus 72 km per hour. Is it? Similarly, velocity of the train B, what can I write here? What can I write here? In south direction, that means minus 108 kilometer per hour. Is it minus 108 kilometer per hour? Now students, in the question what they are asking here, velocity of train A with respect to train B. Is it? So see here, velocity of train A with respect to train B is given here anyhow. VA minus VB, opposite direction means 72 minus 108. So what this will come here? If we will simplify this here, students, 72 minus 108, 8 plus 2 is 10, and 108 plus 2, 108 plus 2, that means 110, and plus this 180 into multiply with 5 by 18. So what will come here? 50 meter per second here, plus 50. Is it? Plus 50, plus 50, plus 50. Now, what they are asking here, students, see. Velocity of train, they are asking B with respect to A, not A with respect to B, they are asking B with respect to A. Now we can understand one more concept that I forget to tell you. B with respect to A means minus of A with respect to B. Is it? That means it will come here minus 15 meter per second here. Is it? Great. Now students, after that, what they are asking here, one more thing here, velocity of ground with respect to B. So see, velocity of the ground with respect to B means here Vg minus Vb. Vg how much here? Velocity of the ground anyhow 0 minus, and B is how much here? Minus 108. Is it? So minus 108, it will become here plus 108, and plus 108 it will come here plus 30 here, plus 30 meter per second here. Is it? Which option is correct here? Option C here. My A here. What we can tell you, see, this is the answer, minus 50, na? B with respect to A minus 50, and ground, velocity of ground with respect to B, how much here? Plus 30. So option C is the answer, and anyhow, this was the real situation. All the time, no need to draw here the situations, hypothetical situations and all. Okay, great. Is it? Now students, we'll go ahead, we'll solve. Now we are going to solve the next question, came in a JEE 2020, important for the NEET also. Okay, so the question is, train A and train B are running on parallel tracks in the opposite directions with speeds of 36 km per hour and 72 km per hour respectively. A person is walking in train A in the direction opposite to its motion with a speed of 1.8 km per hour. Now, speed of this person as observed from train B will be close to how much? Who is going to observe? The train B person is going to observe. Okay, so let's say here two trains are there on two different tracks, otherwise they will hit. Is it? So train A and B is there. What is the speed of the train A? Let's take the train A is going in this direction, no? And train B is going in opposite direction. Anyhow, mathematical sign convention, positive x direction, negative x direction. Okay, so we'll write here one by one. So we can tell what is the speed of the train A. It is given here 36 km per hour here. No? And now we should know very well. No? We know also very well 36 km per hour means just multiply with 5 by 18 and you will get here 10 meter per second here. Is it? Now if we talk about here the velocity, if we take the direction consideration. So velocity of train B is given how much here? It is given here 72 km per hour in opposite direction. Is it? So I can write here minus 72 km per hour, or it will come here minus 20 meter per second. Okay, this thing is done. Now what is given? There is one person in train A. Is it? He is going in which direction? You can see I have highlighted it is going in a opposite direction. Okay, person, one person or one man is there. Okay, so here what we can tell, velocity of man, or we can tell velocity of person even. Is it? We can tell velocity of person, VP. So here we can write here velocity of person. Anyhow, he is moving in a train. So velocity of person with respect to train A. How much here? In this direction. Is it? So you know very well anyhow, sign conventions here. This side plus, this side minus. Na? Mathematical sign convention. So what this will come here? It will come here minus 1.8 kilometer per hour here. Now, so minus 1.8 kilometer per hour, just multiply with 5 by 18, it will come minus 0.5 meter per second. Okay, all this data is ready now. Now we have to calculate speed of this person as observed by train B. That means who is the observer? The train B, or the passenger sitting in train B is the observer. Okay, so what we can tell here, see the velocity of person with respect to train B is given by, we can write here, see, Vp minus Vb. Is it? Even whenever this kind of situation is coming, like velocity of person with respect to B. So what can I write here, see? The velocity of person with respect to train A plus velocity of train A with respect to train B. Now that is the normal basics are there. Okay, or if you want to see in a detail, so see, even I can write here, see, here I can write here, see, I can write here, see, this one here, Vp minus Va plus Va minus Vb. Is it? When you will simplify this, you will get Vp minus Vb. Why? Because minus Va and plus Va will cancel out. So I am telling velocity of person with respect to train B means velocity of person with respect to train A plus velocity of train A with respect to train B. Is it? So now velocity of person with respect to train A, how much is given here? Minus 0.8 minus 0.5, okay, minus 0.5, is it? Plus velocity of train A with respect to train B means Va minus Vb, is it? So what is Va? Va you can see 10 minus minus 20, is it? So what this will come? Minus 0.5 plus 30, that means it will come here minus 29.5 meter per second. That means the train B will observe that this person is moving in the negative direction with how much speed here? 29.5 meter per second. Which option is correct here? The correct option is here 29.5 meter per second. From the direction sense, we can tell in a west direction. Is it very clear? Now students, let's move to the next question. Came in a JEE 2017, important for NEET. So see, a car is standing 2 meters behind a bus which is also at rest. Okay, the two start moving at the same instant but with a different forward accelerations. Okay, now the bus has acceleration 2 meter per second square and the car has acceleration 4 meter per second square. The car will catch up with the bus after a time. Okay, so here bus and car both are moving. Who is going to catch the bus? Car is going to catch the bus, is it? And bus is standing backside of the car. So see here, basic. Now this is car. The car is going to catch up the bus. Okay, so first I will draw here the bus. Now, this is the bus and let's take here car is there. Is it? Both initially in a which situation? Rest situation. Na? They told that. See here the one keyword is there also. That means car is at rest, bus is also at rest. Is it? So we can tell here velocity of car and velocity of bus both are how much here? 0. Okay. And after that, if we talk about here that distance between them, how much is given here? Anything is given? 200 meters here. It is given here 200 meters. So if in case I write here, see this thing here, see this one here, is it? So this is how much is given here. Let's take here, this is S. So S between them is given here. At that instant, S is 200 meter here. Is it? 200 meter. No? And mathematical sign convention, right side positive. Is it? So plus 200 meter. After that, if we talk about here the acceleration, their accelerations are different. So see here, bus has acceleration of how much here? If I talk about the acceleration of the bus, it is 2 meter per second square. Similarly, acceleration of the car, how much here? It is given 4 meter per second square. Definitely by common sense also we can tell the car should accelerate more compared to the bus, then only car can catch the bus, is it? So in this situation, what is happening that here, both the objects are moving. So what to do here, let's take, I have stopped the car B. So the moment I have stopped the car B, I have stopped. So when the car B in a rest situation, that means who is the observer? The car B is the observer, is it? And here car C. The car C will move towards the car B with how much initial speed? UCB, is it? Speed of car with respect to bus. Similarly, if I talk about here the acceleration also, so acceleration of car with respect to bus, because bus in a which situation? Rest situation. And anyhow, this distance, how much is this? Distance of car with respect to bus, is it? So I think so. See, this is the actual situation, real situation. R means real situation. After that, if I talk about this one here, see, this is the relative motion situation, or we can tell virtual situation, so that we can solve the question very easily, because one of the object, or we can tell bus in a which situation? That situation, is it? So now see here, if I write here, see velocity of car with respect to bus, how much? Anyhow, UC minus UB UC minus UB, it will be 0. After that, acceleration of car with respect to bus, how much here? AC minus AB. AC is 4, AB is 2, so 4 minus 2, it will come here 2 meter per second square, okay? And anyhow, this distance SCB, now distance, or we can tell even displacement, because moving in a straight line without changing direction, is it? So anyhow, what is this here? Plus 200 meter here. Mathematical sign convention I am following, okay? Now I am going to use the equation of motion. Remember that here, whether first equation of motion, second equation of motion, they are applicable for the relative motion also, okay? So see here, I can write here S equal to UT plus half AT square, is it? And for relative motion means C with respect to B, C with respect to B, C with respect to B, is it? So see here, the displacement or distance traveled by car to catch it, how much here? 200. Now how much is given? Yes, 200 is there. Now just see, 200 is equal to UCB is any how much here? 0. So 0 into T means 0 only, plus half. Acceleration of car with respect to bus, how much is given here? 2. And in how much time it will catch? Let's take T time here. Why T time? Let's take here time is T equal to 0 and here time is T equal to T. Is it? So when you will simplify this, 2 and 2 cancel. So we can write here T square equal to 200. Is it? That means what will come here, students? This T will come here root 200 second. Or root 200 second means we can write here even 10 root 2 second. Is it? So 10 root 2 second means where is the option here? You can see very well. The correct option is here, option C. So as we are learning, this relative motion is not only for relative velocity, we can use for relative acceleration or even in a equations of motion also. Even in equations of motion also, we can apply this relative motion. Is it? Great. Now students, let's move to this question. What is the question? Came in a NEET 2009 question. Okay, so see here. A bus is moving with a speed of 10 meter per second on a state road. Now, a scooterist wishes to overtake the bus in 100 seconds. Now, if the bus is at a distance of 1 kilometer from the scooterist, with what speed should the scooter chase the bus? Now, so scooter is going to chase the bus. So first let me create the situation. Let's take here bus is there. Now, this bus is there, and let's take here somewhere here scooter is here. Is it? Scooter is there. Now after that here the bus is moving with how much speed is there? Nothing is mentioned, means always in this direction. Bus, and this bus how much is given here? It is given 10 meter per second. Is it? So this VB I can write here 10 meter per second. Is it? 10 meter per second. Here even I can write here, see VB is how much here? Plus 10 meter per second. Mathematical sign convention. After that, as the scooterist wants to chase the bus, so anyhow his speed will be also in this direction, and Vs should be greater than Vb, then only scooter can chase the bus. After that, if we talk about here how much distance is there between them, so see here, this one how much is given here? It is given here how much? 1 kilometer. See here, this is given here 1 kilometer. So I can write here this as of now. S is given here what here? 1 kilometer. Is it? Distance between them how much is given? 1 kilometer. And time, in how much time wants to chase? Chase in how much time? 100 seconds is there. Na? So it is, see here, T is given 100 seconds and we have to calculate this Vs. Is it? Nothing is mentioned. In a previous question, acceleration was there. But here, nothing is mentioned. That means they are moving with a uniform velocity. Okay? No equations of motion. The equations of motion when uniform acceleration is there. Okay? So this is my which situation? Real situation. Now, after that, we want to make here the hypothetical situation. Let's take, I have stopped this bus. Bus in a which situation? Rest situation. Then this this scooterist. Scooterist is there. This scooterist is there. He wants to catch up the bus. Is it? So anyhow, now in this situation, distance between them was how much here? Like this. This was S was there. Na? So here it will become now SCB because bus I have stopped. Na? So see here. What we can write here? Here I can write here, see, velocity of scooter with respect to bus. Na? Because bus is stopped. So Vs minus Vb. Vb how much here? 10, and Vs also same direction. So we can write here Vs minus 10. Is it? After that, if I talk about here, distance traveled by scooter with respect to bus, anyhow, how much it has to travel? It has to travel here, same 1 kilometer. 1 kilometer means how much here? 1000 meter, na, because answers are there in a SI unit. See all the options, meter per second, na. Now after that, you know very well, speed equal to distance by time, na, speed equal to distance by time. So we can write here relative velocity I am using here, na. So relative velocity, see, VSB is equal to distance SCB by time. Is it? Speed equal to distance by time. Now I can write here, see, this will become here Vs minus Vb. Is it? We can write here, see, Vs minus Vb is equal to SCB, how much here? 1000. Is it? And time how much is given here? 100. Is it? So it is coming now, 0, 0 cancel, 10. Now we can write here Vs minus Vb, how much here? 10 anyhow. So Vs minus 10 equal to 10. So what we can tell, this 10 will go this side, so it will come here 20 meter per second. That means the scooter should move with a how much here? Constant speed, or if the direction is not changing, uniform velocity with how much here? 20 meter per second. Is it? Option D. So if a scooter wants to chase the bus, speed will be anyhow more than 10 and it is coming 20. Is it? Very correct, very correct. Okay. Now students, let's see the last question, important for NEET and JEE, and here motion under gravity is involved. Okay, see very well, very important question. A ball is dropped from the top of a building of height 80 meter. At same instant, another ball is thrown upwards with speed 50 meter per second from the bottom of the building. The time at which balls will meet is. So when this question, you will think from the normal perspective, you will think, okay, one ball is coming down, one ball is going up, at some distance they will meet. So this question, by this approach also you can solve the question. But here what is there? Both the balls are moving, you have to focus on both the balls. Okay. But students, if we stop one ball, that means if we apply the relative velocity, this question can solve in a very easy way. Why? Because see here, I am just drawing here the situation. No? So see here, two balls are there. No? There is a one ball and here also one ball is there. Let me draw here. Here also one ball is there. Is it? So let's take here, this is first a ball is dropped. So I am talking about this ball. This is the first ball and let's take this is the second ball. Is it? First ball. So when the ball is dropped, you want how much here? 0. Is it? Now after that here, height of the building how much is given here? Let's take height of the building is given here 80 meter. Is it? How much is given here? 80 meter height of the building. After that, another ball is thrown upwards 50 meter per second. So see here, this is a 50 meter per second. U2 is a 50 meter per second. Mathematical sign convention, I will use it here, upward plus downward minus. Is it? And after that, what is given? They are asking the time at which the balls will meet. So ball 1 is going down, ball 2 is going up. Now you see the magic. What magic is there? What I am going to do here? I am going to stop ball 1. Ball 1, it is going to come in the rest situation. Magically, virtual situation, ball 1 in the air itself in a which situation? Rest situation. So what will happen that here? Now ball 1 will be in a which situation? Rest situation. So see here, here it is there now. So this ball 1 is there and rest situation, U1 is 0. Is it? Rest. Rest. Before that it was dropping. Now rest situation. Is it? Now ball 2 will move. Ball 2 will move towards ball 1 with how much velocity? U21, velocity of 2 with respect to 1. Is it? So see here, individually you know very well U1 equal to 0 and U2 how much here? Mathematical convention 50 meter per second. Is it? After that, as I have the stopped ball 1, so velocity of ball 2 with respect to ball 1 how much is there? U2 minus U1. So anyhow what is coming here? 50 meter per second. And now you very well under the, because they are moving under gravity, gravity is acting in which direction? This direction. That means here velocity is constant? No, velocity is not constant because velocity of first ball is increasing, velocity of second ball is decreasing, na? Because gravity is involved here. So in this situation, acceleration also there. So we have to see acceleration also. So acceleration of 2 with respect to 1, how much is there? See, this will become here A2 minus A1. Okay. And you know very well here, even for first ball also you can see gravity will be downward. On first ball, gravity in which direction? Downward. Even on second ball also, gravity in which direction? Downward. Is it? And the downward convention is what? Minus. You can see minus is there. Is it? So A2 is minus G. A1 is also minus G. And the most important thing is coming for motion under gravity. If we see relative motion of 2 balls, 3 balls, 5 balls, acceleration of one ball with respect to other ball will be how much? Always 0, because both are experiencing the same gravity in the same direction, that means downward. Make it star sign directly. They used to ask acceleration of the ball 2 with respect to ball 1, how much here? 0, because both are having the same acceleration. Okay, after that, what I am telling you, I will use the equation of motion. Why? Because g is the uniform, is it? Uniform acceleration. So I can write here s equal to ut plus half at square, is it? And here I will use for the relative, 2 with respect to 1 displacement, this 2 with respect to 1, this also 2 with respect to 1, is it? So this is here for the relative motion. I am using the second equation of motion. Most of the time, first equation of motion and second equation of motion can be used for the this one, relative motion, is it? Most of the time, maximum to maximum, we will always use this only. Okay, so now see here, now ball 1 rest situation, is it? Ball 1 rest situation, and ball 2 is going to catch ball 1, going to meet ball 1. How much it has to travel? S21, is it? That means 2 with respect to 1. How much is given? This S21 is 80, is it? So say will write here 80 is equal to plus 80, upward see, positive 80. U21, how much is there? U21, you can see here 50. And in how much time? T time. Why? Let's take here initial time is here t equal to 0, and let's take here when they are meeting, time is t equal to t, is it? So 50t plus, most important, this A21 is how much here? 0. So this will make it 0. So from here we can say here t equal to, we can write here 80 by 50, 0 0 cancel, then it will come 8 by 5, and it will become here how much here? 1.6 seconds. Which option is correct here? You can see very well the correct option is here, option A. And in this question we have understood very well, for motion under gravity, acceleration, relative acceleration will be always 0, very very important, is it, students? So I hope so this video of relative velocity concept and questions is very very clear to you. With this we are just ending the straight line motion. Keep studying, keep growing.